G'day, Year 12. In this lesson, I hope to help you understand the very specific meanings that NESA has for the verbs that you see in assessments, including the HSC. But to get the most out of this presentation, I would suggest that you print all of your slides in color if possible, and then annotate them as you watch the video. It's intended that you'll start and stop this video as necessary to give yourself time to read and think and write. I'm going to try to resist the temptation to just read the words that are on the screen, so you'll need to make some time to do this yourself. The good news is that NESA is deliberately moving away from the black magic voodoo of verbs that they had relied on to assess students in the previous iteration of this course. But the bad news is that some of the verbs are here to stay. I started my preparation for this presentation by tallying up all of the verbs that I found in the 2019 HSC, and I've included them in slides that follow in decreasing order of frequency. So the first verb that you'll see, explain, appeared the most often. I have also included one verb that didn't appear in the 2019 paper, but that I predict is going to appear in a paper very shortly. In this presentation, I'll introduce scaffolds that will help you to frame an answer that will hopefully attract maximum marks. Then we'll practice applying the scaffold to the sample answers provided by the exam's authors. It's important to remember that the sample answers are intended to demonstrate what the authors thought students might say. So that means that they're not always the best answer. I've even seen some cases in previous years where the sample answer didn't reflect the marking guidelines that were actually developed in the marking shed, and therefore the sample answer wouldn't have earned top marks. So, as I said a moment ago, by far the most common verb in the 2019 HSC was explain. The most important thing in writing a good explanation is to link each idea together into a chain so that you don't leave the marker to connect your ideas for you. So take a few minutes to just study the scaffold, and then we'll put it into practice on the next slide. Consider the practice question and take a few minutes to jot down some ideas that you might have for answering it. And when you're ready, continue the video to see the sample answer. You might notice, first of all, that it's highly unlikely that the sample answer would fit into the 8 lines provided for responses in the paper back in 2011. This is common in sample answers. Remember that both the sample answer and the lines on the page are a guideline, but neither is perfect. And try not to stress about this too much. With practice, you'll find that most of your answers will fall fairly naturally into the lines provided, but this is only with practice. And the reason for all of those colors is going to be evident in a moment. Notice that the sample answer begins with a description of what a buffer actually is, and any relevant chemical equations should always be included as key terms. The body of the answer is then given over to an explanation of the key terms, an explanation of those reactions. In this case, we are explaining how the buffer system defined by the question resists changes in pH when acids and bases are added. And we start by describing the relationship between adding H3O+ and the buffer's response. Then we describe the relationship between the addition of hydroxide and the buffer's response. And finally, we conclude by linking the maintenance of pH to the definition of a buffer that we gave in our topic sentence. So the whole answer is brought back to the place that it started from. Calculate appeared as many times in the 2019 paper as the next 5 verbs put together. I have no specific scaffold for this because there are so many different types of calculations that you might be expected to do, and each one kind of has its own scaffold. So for example, if you were looking to predict the volume of carbon dioxide that might be evolved in a in a reaction, that would require a very different scaffold than, say, a KSP calculation that might depend upon an icebox. But the important thing with Calculate is to remember to, first of all, always include relevant balanced chemical equations and include these with states, because at one time through an HSC paper, you will be penalized 1 mark if you've not got the states in there when they need to be there. You should show all of your working, and you should never ever round an answer until the very, very, very last step. And you should always report your answer to the correct number of sig figs. Now, there's not any need to identify the number of sig figs that you're reporting. The marker will count those sig figs for you. But if you're in the habit of putting in brackets after your answer 3 sig figs, for instance, just go right ahead. It's not going to hurt anything if that's your habit. So the next verb that we're going to look at today is called is outline, where we just sketch in general terms or indicate the main features of. This would be considered quite a low-level verb, one that's intended to be fairly easy to answer, and you might get a very small number of marks for doing this, or you might get a more kind of moderate number of marks. This particular question appeared twice in only 4 years. Stop and ask yourself what you would say if you were asked this question. As you can see, the sample answer doesn't make particularly faithful use of the verb scaffold. And for only 2 marks, this sample answer is probably sufficient. But let's look at how the answer could be improved further with a better use of our scaffold. The purple text is what I would add if time and space were not an issue. You can maybe see that this purple text just puts our natural indicator into a bit of context and makes the answer a bit more sophisticated. Justify is a verb that only appeared once in the 2019 paper, but it was one of the most common verbs in the years previous, so I expect that it would feature much more regularly in years to come. Now, I actually marked this question back in 2011, and I've forgotten a lot about how we marked that question, all the nitty-gritty little details. Most of that I've forgotten. But something I do remember very, very clearly is the number of responses that said the Arrhenius definition was widely used in junior high school because, being less sophisticated than Bronsted-Lowry, it was easier for younger students to understand. It was pretty obvious from reading all of those answers what teachers had been saying in their lessons, and it was also pretty obvious that Year 12 students were feeling a bit smug. If you were about to write this yourself, stop now and take a look at the sample answer, because that didn't pay. This is another sample answer that doesn't fit very well into the scaffold. The scaffolds, of course, are written to apply to every possible justify question that might be encountered, and in every HSC course, not just chemistry. Additionally, HSC exam items are written with a targeted performance band in mind. This question had a targeted performance band of 3 to 5, meaning examiners expected that most students in band 3 and above stood to do well, but that the question wouldn't allow adjudicators to distinguish between band 5 and band 6 students. Therefore, the answer really needed to be, it only really needed to be a definition of each acid theory and then several points to defend the continued use of the Arrhenius theory. A question with a more nuanced answer would have used more parts of that scaffold, but it was difficult to find a justify question from pre-2019 that we have also covered in the first half of our new course.